Okay. Hey, so you enjoying BriForum so far? So I really have tough competition for this session. A lot of interesting stuff going on now. So thank you very much for joining me here. Hopefully you'll find this session to be interesting as well. The topic of this presentation is HTML5 browser-based remote access clients from the inside out. It's quite a long name, but don't worry. I'll explain what I mean in a minute. My name is Dan Shappir. I'm first and foremost a software developer, so I'm not an IT guy. We have IT people in our company. It's not me. My role at Ericom Software is that I'm CTO and VP R&D. We make an RDP remote access solution in HTML5. So for this reason, I will not be doing a product comparison or shootout or smackdown or whatever term you choose because, well, it won't be fair. But what I will be doing is I will explain how it works on the inside, and I'll also hopefully be able to give you some tools that you will be able to understand when this type of a solution is preferable, when it isn't, and also how you can compare the existing solutions that are available out there right now already. Also, I just think it's plain interesting to understand how this type of technology works because it's very different than how regular remote access solutions work. So I just, from the developer and me, I think it's an interesting topic. You also have my Twitter account, my blog up there. I tweet more than I blog, at least for now. But I do both, and this is a topic that interests me a lot. So if it also interests you, you will be able to find information about that on my tweet and on my blog. So these are the topics that we will be covering in this presentation. We will start with a definition of what HTML5 remote access is. And we'll talk about when it's a good idea and when it isn't, why you would want to do it and why you may not want to do it. I'll also do a quick rundown of the companies that do provide solutions in this space. Again, not a comparison, more of a sort of a list or a rundown. And the most important part of the session will be a discussion of how this technology works and what we can look forward to in the next couple of years in this category. So let's start with a definition of what this is. First of all, in my opinion, HTML5 remote access is one of the most significant developments in remote access technology in the past, let's say, year or two, for sure. Maybe even longer, but in my opinion, for sure, in the recent time. Because it really changes what you can do in remote access. What we've seen in recent years is like an evolutionary improvement. You get better protocols that can address more situations. They make better use of available hardware. They do hardware-based acceleration, but it's very evolutionary. This is like a first time in a long time that remote access clients have effectively been rewritten from scratch and rewritten in a different way than the way that they were written before, and run in completely new environments and use different types of protocols to get the content from the host to the endpoint. So the client is a web page. No more, no less. That's what it is. You download the client like you would any regular web page, brianmadden.com, google.com. It's the same sort of thing. It's just a web page running in the browser. This means that the client side runs completely inside the browser window. If you're thinking about stuff like seamless windows and various other forms of desktop integration, that's not relevant in this context because, again, as a web page, the client is wholly contained within the browser tab. The client is also implemented completely using standard web technologies. So we're talking about stuff like HTML, CSS, JavaScript, stuff that I went into in more detail in my other session on HTML5 in general. But these are the building blocks. Such clients can use browser add-ons if they're available, but should also work if they're unavailable, which means that they shouldn't be dependent on add-ons. For example, TeamViewer have a browser-based client, but it's implemented using Flash. So based on this definition, that's not the type of client that I'm talking about in this presentation. Here are a couple of online demos. You know what? Let me start. These are demos that I found that you can easily use online. Other companies also offer online demos. I just, for some reason or another, was not able to use them. So I just chose the ones that I was able to use. Let me show you one or two of them quickly. So let's do that on an iPad to make it even more interesting. So, okay. Let's see. Is it working? Okay. Yes, it is. Okay, so here I am inside a browser. We can see the BriForum agenda. I'll open another tab. And let's start with a browser-based client from a company called InstallFree. It's a product called InstallFree Nexus. I'll go into more detail about this type of a client. Basically, it integrates with file sharing services like SkyDrive or Dropbox. So I'm going to use my Google account to log in. You can see here I am. Okay, it's logging in. I've synchronized both my Dropbox and my Google Drive account with it. So we'll go into, let's say, this thing. And we can see that we can select this actual presentation. And I can actually, and here it's in a preview type window. I'll click the open in PowerPoint. And here I'm actually getting a PowerPoint. And as you can see, it's PowerPoint running within the browser on an iPad. And I can actually work here. And I can click and type stuff in here. So this is all done via browser HTML. So this is one product or service in this case. It's not actually, I would define this as a cloud-based service rather than as a product. Another demo is that I'm obviously familiar with is our own demo. Actually, a couple of demos that are available online. By the way, our demos are running, I can tell you, are running off of the Amazon cloud. So I can click here and get a full Windows demo, hopefully, running in the cloud. I was really scared. You know, I'm doing this from an iPad, and I was worried that with all the Apple downloads, I won't get any connectivity, but I see that so far it's working well. So I can launch another Office application. Oh, yeah, I have a problem, okay, with this. Okay, so I can click here, and I can open it. I can type and do return, and okay. So as you can see, you know, obviously this is not, you know, and at the end of the day, what am I showing here? I'm showing remote desktops and applications on Windows desktops and applications on an iPad. Obviously, this is nothing new. You know, Brian made fun of these types of apps, of this type of remoting during the keynote. So there's nothing really new here. What is interesting here is that it's running inside, as you can see, it's running inside the browser window. I can switch between the various browser tabs. They're all here. And, you know, and now I'll switch back to my desktop if I can find the connector. And I can obviously do the same thing here. So I can do the exact same demos in a browser on my desktop. So this is just in order to show that this type of a solution works on any device, any type device from within the browser window. And again, I can just go here and type and do whatever. And again, it's running in the browser. And it's implemented completely using web technologies. It's not using anything like a plugin or an ActiveX or whatever. It's just pure HTML. Okay. Okay. The role app one you can try by yourself. It's another interesting example of this type of application. Interestingly enough, they're not actually accessing Windows desktops or applications. They're actually, at least in this version, running applications off of a Linux server. So in their case, it's primarily stuff like OpenOffice or LibreOffice installed on a Linux server. Okay, so let's talk about the why. What's the value? What's the benefit of using an HTML5 client for remote access? So the primary benefit is rather obvious: no installation. The whole concept or one of the main benefits of centralizing desktops and applications and resources is to reduce the overhead of managing the endpoints. But you can end up having to manage the endpoints again because you basically need to manage and install and configure that software that enables remote access. And you need them to install, let's say, a Citrix client or a VMware client or an Ericom client and configure it to connect to the appropriate server at the appropriate address. You need to make sure that they're using the proper version. If a new version, let's say, of Citrix Receiver comes out, you need to make sure that they upgrade, especially if you're using some of the newer features. What can get even worse is a situation in which you may have to do rollback. If one of the vendors releases a version that for some reason isn't good or is not compatible with your existing infrastructure, and you need to get your users to roll back, especially on these devices like the iPad, where you have little control over the versions that they're using, something like that can be very, very difficult. So by using a browser-based solution, all this hassle is gone. Basically, the client is, as I said, is just a web page. You send them a URL, and bam, they're connected. So in case of a disaster recovery scenario where you have people you want to be able to work remotely, you can basically put a URL on Facebook or Twitter, and they can click it, and they're connected to the backend resources, desktops, applications, whatever. Related to that is something I call assumption of responsibility. I guess all of you as IT professionals are familiar with that. A person, one of the employees comes in with an iPad, gives it to you because you need to install a remote access client, and then a couple of days later it comes back and says, since you installed that client or whatever software that you installed, I have all sorts of problems with it that I never had before. Stuff that was working before isn't working anymore. Now, you may know that the things have nothing to do with each other, but from his perspective, the moment you installed software on his device, the moment you change configuration on his device, if there is any problem with his device or her device, it's your fault. Now, it's not surprising that they take this attitude, because this attitude is an advantage. There's an advantage in it for them, because from that point on, it's your responsibility to make sure that their device is properly working. With an HTML5 remote access solution, there's no assumption of ownership, because basically, it's just a web page. You're not installing and configuring anything. You don't have to do anything on their device. You don't have to physically touch or alter their device. You just email a URL to them, and that's that. Other benefits include, embracing BYOD. We keep talking about that. Support for lockdown devices. It could be a device in an airport, in a hotel, device that you either cannot install a remote access client on, or cannot launch a remote access client from. It could be a device that you don't want to modify because, let's say, you're visiting a relative and you just don't want to install stuff on their device. Again, you just launch a browser and you're good to go. It could be devices that don't support native apps. So I've got a Chromebook here somewhere. Chromebook, for those of you who are familiar with it, runs Chrome OS, this operating system from Google, where you cannot install any native app. It only supports HTML5 applications. Firefox, or the Mozilla organization, recently announced Firefox Mobile, a mobile operating system that's essentially just a browser running on the smartphone hardware. And again, all software on that type of a device will be HTML5 type web apps. So again, that's the only way to support these types of operating systems. Integration with any web app on any device. Think about it this way. Let's say you're an organization that has a portal or some other web page that's like the entry point or where employees access their information. A good example is something that we encounter a lot is with universities, where they have a web page or website where, let's say, students and faculty go to access relevant information. And they wanted to add some additional functionality, but that functionality wasn't available as a web application, but they still wanted to integrate it into their website in a way that would work on any device. Now, I don't know if you know this, but on a lot of the modern devices, like iPads, like the new Windows tablets, the WinRT tablets, in Metro mode, you can't really integrate the launch of native applications into web pages, because the web pages are effectively what they term as plugin free. They don't run any attachments or plugins. So using an HTML5 remote access makes it possible, in fact, very easy, because again, it's just like you can either put it in a frame inside the page or launch in a new tab. In any event, it's just, it's as simple as connecting any other web page into that existing web interface. Support for SSL VPNs without agents. SSL VPNs have two main modes, you can say. One mode is a mode where you use it to access web applications or web servers that are sitting inside the organization. So you're using the browser as your front end. In this mode, the SSL VPNs function effectively as a sort of a proxy, and you don't need to install any agent on the endpoint device. The other mode that SSL VPNs support is a sort of a tunneling mode, where you need to install an agent that tunnels all the traffic, whatever traffic it is, through the HTTPS, through the SSL VPN into the organization where the protocol is unwrapped. Now, for that to work, you actually need to install an agent on the endpoint device, and this could be problematic, again, because you may not be able to install an agent, or maybe an agent is not available for that particular device, or there are problems with privileges or the rights to install such an agent. With an HTML5 remote access solution, because it's a web page, because it's using standard web technologies for communication with the back-end host systems, it just works through the SSL VPN without requiring any agent on the endpoint device. And finally, effectively, what you get when you use HTML5 remote access technologies to access specific web applications, you've effectively achieved turnkey webification of that specific Windows application. So if you have a Windows application and you want to transform it into a web app, instead of rewriting that entire application, you can use an HTML5 remote access solution to effectively webify it like this. Okay, any questions so far? Okay, thanks. There are also some reasons not to use HTML5 remote access. There are definitely advantages to native apps. So first and foremost, the question that comes up a lot, performance. What is the performance of HTML5 remote access? Actually, I think that you saw from the demos that I was giving before that performance is actually acceptable for a lot of scenarios and can be good in a lot of cases. But if you're really looking to get the most performance out of your existing platform, then optimized native apps will give you more performance than HTML5 remote access, certainly in the, let's call it the edge conditions. If you're doing, I don't know, 3D stuff, then for sure. Local desktop integration, we were talking about it before. HTML5 remote access runs wholly within the browser tab. So stuff like seamless windows or reverse seamless or all this sort of thing is just not relevant in the context of HTML5 remote access. Session sharing, because each app runs in a different tab, if you open multiple apps, they actually run in separate sessions. If you want multiple apps in the same sessions, you probably need to publish a desktop. So that's another thing you may be losing. Access to local devices. As we will see, assuming I don't run out of time, HTML5 remote access can actually get at some of the local device functionality, and that will actually improve as browsers get, modern browsers get enhanced functionality in that regard. But if you really need access to all type of devices, and especially, I don't know, weird devices like point of sale devices or whatnot, then you do need a native client. Keyboard turns out to be a surprisingly difficult issue sometimes with the remote HTML5 remote access. In particular, if you're looking at various locales, you really would need to look at the solution that you're checking to see that it properly supports the locale that you need to support. And since you're running on top of the browser, so you're adding another layer to the infrastructure. You're not, the native client runs directly on the operating system. In the case of a browser-based client, the browser is running on the operating system and you're running on top of the browser, then obviously you're susceptible to any browser bugs or compatibility issues in the browsers. And finally, you know, native clients have been around for 20 years or so. Browser-based clients have been at best around for 2 years. So, you know, 10 times as longer. So obviously the native clients are more mature and more robust than the browser-based client, especially given, as you will see, that many of the browser-based clients are actually still in beta. This is an interesting example. This is my living room, and we recently bought a new television. It's a Samsung Smart TV, and it has a built-in browser. And here's Word, that same Word example that you were seeing before, running in my living room on my TV in that smart browser. So this is an example of what I mean by accessing Windows desktops, applications really from everywhere. And you know, in the not too distant future, you will have HTML5 browsers on your fridge, in your car, practically everywhere. Yeah. Potentially, yeah, because each app runs as a separate tab, and you can't, well, at least we've not found an effective way of making a tab appear to be like a monitor. So effectively, in order to get like separate tabs and the app completely filling the tab, you end up having separate sessions for each tab. In most cases, when a customer right now comes and tells us that he really needs a lot of sessions, we recommend publishing a desktop rather than publishing the individual apps. Or we let him know, okay, but you will be using several sessions when you're doing it. Now, this is not relevant for some of the other solutions. For a solution like InstallFree, when they're just sitting on top of a file sharing service, you know, the whole concept of sessions is kind of not relevant. But if you're accessing terminal services, for example, RDS, I'll never get used to it, RDS session host, then yeah, that's something to watch out for. So these are some of the existing solutions out there. There might be others that I'm missing. Citrix Receiver, to be honest, I'm not exactly sure what's going on with that. They released a version specifically for Chromebooks on December 31st of last year. I've heard that they're going to be releasing a version that supports additional platforms and browsers sometime soon. but I've seen no official indication of that. I don't know, maybe it's synergy. If anybody knows different, you know, let me know, please. ThinVNC and ThinRDP from a company called, I think they pronounce it Cybele. First they had ThinVNC, then they introduced ThinRDP. It's a product that exists right now. Our own Ericom Access Now solution, an open source project called Guacamole that also started just with VNC and then added RDP later on. Install Free, which we saw before, which is, I think, beta, the second beta version or something like that. A company called NextGenIt, which I've seen but don't know much about. Another open source project called NoVNC that kind of competes with Guacamole, but it's only about VNC. Another company that does RDP-based remote access called Remote SparkView, Rollup, which I mentioned before, which are also beta and only access Linux-based systems running in the cloud. VMware AppBlast. You know what? I'll start with the other VMware solution, VMware WSX. You may have seen that. That was released as a tech preview on top of the latest releases of VMware Workstation. Basically, it's like integrated. It's like a browser-based management solution, and you can actually do remote access to the VMs from within the browser. And VMware AppBlast, which I guess we've all seen a demo of at the last VMworld, but since then I have no idea what's going on with it. And again, if anybody here has any information about, you know, what's happening with it, I'll be most interested in this information. Any comments or questions about any of these solutions? Yeah.
Do you guys do anything inside of your client to accelerate performance?
I'll get to that. Hopefully, unless I don't run out of time. I have much too much content in this session. Okay, what I want to emphasize though is that with all these clients, again, this is not a comparison, but I do want to give you some tools that you can use to compare different solutions. So it's important to understand that these solutions were not created equal, and in fact were not necessarily created for the same purpose. Some of them are on-premise solutions, the solutions that you install on site to connect to a VDI solution or a terminal server. Others are cloud-based solutions that integrate with file sharing software, and some of them do both. Some have integration with connection brokers. Some have integration with, so for example, our solution integrates with connection brokers. Install Free integrates with file sharing. And there are some solutions that don't integrate with anything. They're just like sort of an RDP client or a VNC client that you can basically just use. Some work with Windows on the back end. Some work with Linux on the back end. Some work with both. Some use or are implemented over an existing protocol like RDP or VNC or ICA. Some implement their own completely new protocol. Some are compatible with most browsers. I hesitate to say if anyone is compatible with all browsers, especially since there are some weird browsers out there. But some are only compatible with a specific subsection on browsers. And you know, I gave the Citrix example before that the last official version is only compatible with Chrome on Chromebooks. So that's like one browser that they're compatible with. So if you're looking at such a solution, you need to be aware of which browsers or which platforms you need to support and make sure that the solution that you're looking at supports these browsers. Can you publish desktops, apps, or both? Does it have an API? That's more interested for companies like, I don't know, DaaS providers that may want to integrate this solution with their offering. And less interesting for somebody who's just looking at this as an endpoint solution. The bottom line is that there's a lot of variation in the availability, maturity, performance, and features of the various solutions. And what this means is that if you're looking at one product and that product isn't appropriate for your use case, don't give up, at least in my opinion, on the entire technology. It's worthwhile to look at other products in this space because another one may be more appropriate for your needs. Okay, so what are the, let's get into the interesting part of talking about how this stuff actually works. So what are the building blocks of any remote access solution, not a technology, not just browser-based? So first of all, you have that communication layer. How does the client actually communicate with the backend system? You've got the protocol that's running on top of that communication layer. What type of data are you sending? How are you wrapping it? You know, if you've been to Benny or Sean's sessions, stuff like client-side rendering versus host-side rendering, that falls into the protocol thing. You've got the actual rendering, also related to what you just mentioned. How is the data received actually drawn onto the screen? You've got the user input, keyboard, mouse, touch, whatever. Access to various devices, audio, printing, file transfer, drive mapping, a USB redirection, whatever. So all of these components constitute the basic building blocks of any remote access solution. So we'll look at these building blocks one by one in the context of browser-based access. So in the native world, when we're talking about communication, we usually talk about TCP, UDP, or both. You know, there's been this whole argument, you know, which is better. ICA is TCP, PCOIP is UDP, and now RFX2 is both. In the context of browser-based access, this is not the comparison. This is a comparison. Do you use HTTP or HTTPS for the communication? Do you use WebSockets? Or again, do you use both? And in the future, and again, hopefully I'll get there in time, we will see there will be additional options as browsers evolve. So let's start with HTTP because this is really the foundation of communication in the web. The web was built on HTTP. So HTTP is obviously supported by all browsers. This is how browsers download content. Despite the name, which is Hypertext Transfer Protocol, it doesn't just transfer hypertext. It can basically transfer anything. You know, when you open a page, everything in that page is downloaded via HTTP. If you're downloading files, anything through the browser, HTTP. The current standard for HTTP, which is starting to evolve again, is HTTP 1.1, has been around since 1999. It's implemented on top of the TCP protocol. And HTTPS is essentially just HTTP encrypted using SSL TLS. So from this point on, I won't say HTTP or HTTPS, I'll just say HTTP. And it can be either encrypted or not, doesn't really matter. So the problem with using HTTP in the context of browser-based remote access is the HTTP paradigm. The HTTP paradigm is a paradigm of request, response, request, response. The browser sends a request, the server responds, this browser sends another request, the server responds again. The client, the connection, the TCP connection is actually reused. So originally it was even worse. It would be a socket opened, request, respond, socket closed. Fortunately, that was changed way back in 1999. So now the same socket connection is actually reused to download more and more content. And in fact, modern browsers, the way that they work, and it actually surprised me the first time that I learned about this, when you visit a website, the browser actually opens up usually around 6 socket connections to that web server, and these socket connections stay open from that point on. And the reason that the browser does this is, first of all, it enables the browser to perform multiple simultaneous download operations. You know, all browsers want to show you the content as quickly as they can, and in order to do that, especially with modern pages that have a lot of graphics and files that are and script files and CSS and whatnot, like a regular page can reference, I don't know, 30 resources. Having 6 sockets that you can use simultaneously makes the whole process much faster. And the other thing is that even when the page finishes downloading, these socket connections remain open. And the reason for that is, first of all, I assume that most browsers take the approach that if you use one page, then the next page you will use will likely come from the same website. So there's an advantage in keeping these sockets open for the time the user clicks on some link again. And also, a lot of modern pages use technologies like Ajax or stuff like that to download additional resources even after the page is fully loaded. So again, they're able to reuse these existing socket connections. But on the other hand, it's important to understand that if you're opening multiple tabs to the same website, so it's not going to turn out to be like 30 sockets connections. All these tabs will reuse the same 6 socket connections. Now again, this number is not part of any standard. It's just a number that most browsers happen to use. So as I was saying before, this paradigm isn't really appropriate for remoting protocols because this whole concept of request response is not how remoting protocols work. And you really have to work hard to circumvent the limitations of HTTP if you use it as a transport protocol for remoting clients. So for example, you've got all sorts of tricks that you can do. And by the way, I kind of skipped this. So, looking at all these limitations, you might ask, well, why would browser-based remote access clients use HTTP in the first place? So the first reason is obvious, up to 2 or 3 years ago or a year ago, they had no choice. This is the only protocol that the browser actually gave access, or that code or web page running in the browser could actually use. A web page in the browser without utilizing some plugin couldn't use any other type of a protocol. So that's the primary reason why HTTP is used. So if you're looking at projects that have been around for a longer period of time, like the Guacamole open source project, they're built on top of HTTP. So there are a lot of tricks that you can use to circumvent these limitations that I've mentioned before. One is polling. A client just does a request, gets some immediate response. It makes a request regardless of if it has anything to send. Just ask the server, look, either it says, here I've got some new stuff because the user clicked the mouse button or something, or just sends a request along of, do you have anything to say? And the server basically immediately responds either with some content or basically saying, no, nothing new. And then the client immediately has to make another request. So it's like ping pong the entire time. Obviously, this is very inefficient because most of the time, nothing is happening. So you're generating a lot of network traffic in order to say, basically, nothing new on my end. To overcome the concept of long polling was invented, which is basically the client making a request and the server basically not responding until it has something to say, and the client just waiting for the server to respond. And when the server has something to say, it can then immediately respond. So this actually makes it possible for the server most of the time to respond, to send information down immediately when it has information to provide to the client. The only times when the server will have to wait is after it already sent something, if it wants to send something additional information before the client is able to send another response. That's the only time that a server may be required to wait. The problem here, though, is that while the client is waiting for the server to respond, the client is not able to send additional requests on that particular line, potentially. So most of these type of solutions actually use multiple sockets at the same time. So that goes to the second point. The client can actually, as I said, there's actually 6 socket connections there. So the client can actually do long polling on, as it were, on one socket and then send information of its own to the server on another socket. Another trick is something called chunked response, which is a mechanism, again, built into HTTP, which basically allows the server to say, here's a response, but this is not the entire response. I have some more information that I may want to send down later. And this way, okay. So again, a lot of hacks and complexity. All of this was really resolved by WebSockets. WebSockets are basically a new technology protocol introduced in HTML5. It's bidirectional, it's full duplex, it's fast. You get a dedicated socket for this particular WebSocket connection. Obviously, much more appropriate for remote access type solutions. WebSockets used to be textual only. Some people still think that they are. They're not anymore. The protocol has been enhanced. It's now fully binary compatible. You can send binary data both up and down and text. And the API is very simple to use. So if WebSockets are so great, why not just use WebSockets? Well, most of these solutions do use WebSockets before that. One key point to remember about both HTTP and WebSockets is they can't connect directly to the, let's say, RDP host. That's because both of these protocols have like headers and a particular format to their packets, and that's simply incompatible with existing protocols like RDP and PCOIP or ICA or whatever. So you have to have some sort of translation layer. WebSockets are faster and have less overhead than HTTP, as we saw, but HTTP does work, just a second, in situations where WebSockets don't. For example, some older browsers just don't support WebSockets, or a lot of SSL VPNs don't support WebSockets yet. I've been told by most of the SSL VPN vendors that they're working on it. I think that actually Citrix, I think, their SSL VPN does actually support, I think, or the next version will support WebSockets. Yes, you had a question.
I thought Windows Server 2012 supports RDP.
Okay, what it does, it has the RDS gateway. And the RDS gateway wraps, it works in this sense like sort of like an SSL VPN. It wraps the RDP traffic. First of all, you've got the Microsoft guys over there, so you can ask them. But it effectively wraps the RDP traffic inside of an HTTPS wrapper. So in that sense, it works like an SSL VPN, but with the SSL VPN agent, as it were, built into the Microsoft RDP client itself. So the Microsoft RDP client is actually able to communicate with the RDS gateway, unwrap RDP out of that HTTPS wrapper, and get at this information. But this protocol, as far as I know, is proprietary, and I'm not aware of any browser-based solution that is actually able to talk directly to the RDS gateway. Because of the limitations of WebSockets and HTTP, the optimal combination, in my opinion, is use WebSockets when you can and fall back to HTTP when WebSockets can't be used for any reason. The protocol. So there are basically two types of approaches that you can take here. You can utilize an existing protocol like RDP, like VNC, like ICA, or you can roll your own protocol specifically for the browser-based solution. Advantages of using existing protocol, first of all, you can leverage the work done by others. The guys from Microsoft, for example, have done a fantastic work with RDP. So instead of doing all this heavy lifting of building a remote access solution, stuff like handling printer mapping and whatnot, you can just leverage this existing functionality and build on top of it. If you want to connect to an RDS session host, you basically have to use RDP or ICA. Really, there's no other way, because these protocols are not just a remote protocols, they actually tie in to the entire session management or session creation mechanisms that are in terminal services. And if you're coming into an existing environment that's already standardized on a particular protocol, it's much easier to build or utilize that existing protocol rather than introduce yet another one. On the other hand, there are advantages to rolling your own protocol. It gives you total control. You know, here you're kind of dependent on how that other protocol behaves, and you may not have, and it may behave in a way that's not really appropriate for what you're trying to do. There are fewer hops. We will see that utilizing an existing protocol actually requires you to introduce a translation layer in the middle, and it's optimized for, it can be optimized for browser use. So using an existing protocol, it could be RDP, VNC, ICA, whatever. As I said, an HTTP or WebSocket client cannot connect directly to such a host. So you need to introduce like a gateway or translation layer to translate one protocol into another. This is a diagram that I stole from brianmadden.com that Gabe created, explaining this. So here you have a web server downloading a client running inside the web browser. You have, let's say, a WebSocket connection going to this gateway or translation layer. And this translation layer then, in this example, translates it to RDP, which can go either to a terminal server or to a VDI type desktop. You have to do this translation because, again, these hosts, you just can't connect to them using WebSockets directly because this is not a protocol that provides you with total binary freedom in the way that you package the packets, as it were. So there are really two types of translations that can go about, and that goes to your question about optimizing the traffic. One is thin translation, which basically does as little as possible in that gateway or translation layer. It basically just takes the original protocol, wraps it either in HTTP or in WebSockets, and sends it down to the client as is. The other type of the advantage in this type of approach is that all the protocol logic is implemented in one place in the client. The other type of approach is something I term thick translation, is where you actually use that you're saying, okay, I'm going to transfer all my bits to this gateway anyway, then I might as well leverage that and introduce some logic in this translation layer. For example, I can convert images that are in a lot of these remoting protocols transport images, and I can perhaps translate these images into formats that are either just more effective because they're more compressed or are just more appropriate for use in the browser. I can optimize the protocol so the browser can better parse it. I can add flow control. By flow control, you know what, I'll just skip this entire, you know what, I'll say it very quickly. The problem is that a lot of these remoting protocols, you know, when you have, let's say you have a video playing, and the video would natively be at, let's say, a frame rate of, let's say, 30, but the network or the client is unable to handle this frame rate. So the protocol introduces, the remoting protocol actually introduces some sort of flow control where it actually skips some of the frames just because otherwise a 1 minute video would run 5 minutes, which would obviously be very bad. Now the problem is that having this translation layer in the middle can sometimes confuse this flow control because from the host's perspective, that gateway is the client. So it thinks that the client is very close and very fast and just keeps shoving frames at it, and it can actually cause a situation where the protocol is basically getting too many frames. And one thing to check is if the content you're looking to remote includes videos or animations, I recommend that you verify that the solution that you're looking at is actually able to handle that. So the advantages of thin translation, you can, as I said, all the logic is in the client side. So you can effectively take an existing, let's say, and a good example is SparkView, which I mentioned before. They had a client for Android implemented in Java. They basically ported this client from Java to JavaScript. Job done. Their translation layer was just wrapping the RDP protocol inside WebSockets. And also, when they have newer versions, it's very easy to distribute the new version because you just put the new version on the web server, and again, job done. You don't have to update the gateway component, certainly not as often. On the other hand, there are a lot of advantages to thick translation. The flow control that I mentioned before, you can add that into the protocol. Optimizing by compressing images, utilizing the browser features, and so forth. Does that answer your question from before, more or less? I think you asked about compressing images. So, mixing with somebody else. Okay. How much time do I have left? Okay. Rendering. Okay, so we got all the data down to the endpoint. How do we actually render it onto the browser window, the browser tab? So most HTML5 remote access solutions use a relatively new HTML feature called Canvas. Canvas, when people talk about HTML5, Canvas is like the thing. This is what most people think about when they're thinking about the new functionality of HTML5, Canvas and WebSockets. So Canvas is a new HTML tag, basically write it like that, which defines a free-form drawable region in the HTML tab. You specify width and height. That defines both the size of the canvas in the browser window and also the pixel resolution of that canvas element. And you have JavaScript API that you can use to perform 2D raster drawing operations within that area. Basically, you can do whatever you want in terms of drawing inside that area using these JavaScript APIs, like you would use, I don't know, GDI to draw stuff in a window in Windows. You have APIs for drawing images, lines, arcs, rectangles, whatever. You can specify styles and colors, and you have the ability to also do direct pixel manipulation. So you can actually add specific pixels, read them, apply any type of formula to them, and write them back or whatever. Canvas is really fast these days, because all the modern browsers, or most of the modern browsers, use GPU acceleration for Canvas. In fact, it's getting to the point where it's actually difficult to create an application that does native rendering of images faster than HTML5 can do in a Canvas region, because the browsers are just so fast. It's very easy to use, and as you saw, it provides a lot of graphic primitives. In fact, all the graphic primitives that you would need in order to implement a remote access client. And because it's the primary HTML5 feature, it's widely supported. All the modern browsers have Canvas. Not all of them have the same HTML5 features, but all of them have Canvas. Even IE9 has Canvas. Here's a very quick example of a canvas. This is actually completely valid, legal HTML code. You can copy that, save it in a file, open it in a browser. Can anybody guess what this will draw? Correct. A red rectangle. You access the canvas, you get a 2D context which you can use to perform the drawing operations. We specify the fill style, we move a cursor, we draw lines, and then we fill this defined area, and you get a red rectangle in the canvas. And again, you could just copy and paste and see it working. So, for those of you who've ever attended Benny's or Sean's, or their sessions, they always talk about client-side rendering versus server-side rendering. Where do the Windows, let's say, drawing primitives get translated, just a second, into actual bitmaps and drawn into the display? Yes?
So, like, you know, the HDX and the RDP8 has adaptive display where they divide the screen into text and the video and kind of, you know, use like H264 type recorders to send it out. So does like the HTML5 line versus maybe the Electron line which is out there, does that have smart to do that? Or?
Not that smart yet. The question was actually specifically about our client, but I'll try to answer in the general context of all the HTML5 clients that I'm familiar with. The question was specifically about how Remote Effects, for example, uses various codecs to encode or encapsulate separate parts of the display based on the type of content that is there, and do existing remoting protocols use logic like that? And what I would say is none of the clients actually, or do they use video for encoding, for example? So none of the existing clients that are familiar with currently use video encoding, although I'll touch on that in future directions where this can go. But I can say that some clients use client-side rendering and some clients only use server-side rendering. So, for example, you know what? Let me get there in a minute, assuming I don't run out of time. So client-side rendering, you basically take the actual drawing instructions like draw a circle and send them down to the client to execute, versus server-side rendering where the circle would be drawn on the server, encoded as a bitmap, as an image, and then sent down to the client to just draw the image on the display. Client-side rendering consumes less bandwidth because the instruction draw a circle obviously consumes less bandwidth than the whole bits that constitute the actual circle. It also has lower CPU side utilization because, again, it's executed on the client side, but there's also advantages to server side. The server side sends information as effectively just as a sequence of images or frames using various codecs. Could be working like a video or just a simple stream of images. The client could be much simpler and less powerful. The modern protocol, remote effects primarily is a server-side rendering solution. But RDP in general supports both client-side and server-side. If you remember what I wrote, the capabilities of Canvas, you'll see that Canvas can support client-side rendering because it has all these primitives like draw circle, draw line, draw rectangle. So if you're looking for efficiency in terms of the protocol, you can look at an implementation that uses client-side instructions to offload some of the overhead from the server side and also reduce the bandwidth usage. But the fact is that most of the existing products that I'm familiar with actually use the server-side rendering for effectively just sending images down and drawing them onto the canvas. So, going to the screen scraping codec, that's the way that most protocols work. If you look at a protocol like VNC, that's just a sequence of images, PNGs, JPEGs, that's it. It's easier to implement because you get the image, you draw it. You get the image, you draw it. It's very simple. The client, in that regard, becomes very, very simple. Also, it has another advantage. It turns out that even though Canvas does support all these drawing primitives, it's kind of difficult to map some of the existing Windows drawing operations into the Canvas drawing operations. This is getting very technical, so just skip that. If anybody is really interested in that, can approach me about this afterwards. And it can be implemented even without Canvas. There are, in fact, a few clients out there that basically just create image objects in the browser. It's less effective, it's less efficient, it consumes more resources, but it does support older browsers that don't even have Canvas. So, you were talking about codecs. So some of these codecs or some of the image formats that are used by some of the remoting protocols aren't really supported by browsers. If you're looking at native RDP, it uses bitmaps, uses run length encoding, and browsers don't natively support this type of an encoding of an image. So you really have two options with these types of images. If you're using thin translation, you actually need to send it down to the client as it is. The client actually implements JavaScript code that does direct pixel manipulation and draws the images directly into the pixels. If you're using thick translation or you're rolling your own protocol, you can in fact send down the wire JPEGs or PNGs or GIFs, and then it's natively supported by the browser, and the browser can just draw them directly as it is on the canvas. This has a couple of advantages. First of all, you can use the GPU instead of the CPU. The browser code, the built-in browser code is much faster than a JavaScript loop. It saves battery. It saves bandwidth because these image formats are often more compressed than a bitmap format. So even if it's an unsupported format is potentially better. Some people have asked, let's say, about the various special codecs that you might have in a protocol like PCOIP. Even if such a codec is able to compress the screen better than, let's say, PNG, if you want to have lossless, it might not be worth it because you would have to write the JavaScript code that would do the direct pixel manipulation in order to support that codec, and that would cost you in terms of performance because it's JavaScript rather than assembly language, it's CPU rather than GPU, it eats up battery, and so forth. Okay? Yeah? Sorry, I didn't hear what you said. Okay, so what Canvas can do is you can actually have a video stream and video on a browser, for example, supports the H.264 protocol. And then you can take the video stream and you get a notification when there's the next frame, and you can actually draw that frame onto the canvas. So you could, and maybe in the future, you could see remote access clients implemented as browser-based clients that, for example, use video protocols to transmit down images to the client side instead of, let's say, just a sequence of JPEGs, something like that. I was actually hoping to get to that. I will probably run out of time before I get to these slides. User input. One thing to remember is the same client. Do I have like 5 minutes or so? Oh, 10 minutes. Oh, more time than I expected. So one thing to remember about these browser-based clients is because that they need, you want, you know, the whole concept is supporting multiple platforms using the same client. When you have a native client, you have a native client for, let's say, for your Windows desktop. So that Windows client was developed specifically to work with a keyboard and a mouse. And you have a completely separate client developed, let's say, for a tablet. And that client was developed to work with touch and a virtual keyboard. When you have a browser-based client, it actually needs to support both. So the same client needs to have the logic or the know-how to work both with a mouse and a virtual keyboard, a physical keyboard if they're there, and work with a multi-touch and virtual keyboard if it's accessed on a tablet. So it's like double the knowledge or double the know-how in the same client, and that obviously adds complexity. I was talking before about keyboard. You know, surprisingly, you know, keyboard support, you know, this has been around forever. I mean, really, the browser manufacturers, this is nothing new. Everybody knows that there are multiple locales, and this is so fucking hard. You know, getting it to work in all the browsers, in all the locales, is just freaking terrible. It seems to be improving, maybe slowly. It's just whatever. Touch events. So whole world standardizes on a set of touch APIs, and then Microsoft comes up with a better set of touch APIs. So now you have to support both. But it's not as bad because you have libraries like jQuery and whatnot that usually you can gloss over these differences. Far East locales, as I said, can be very difficult to implement, especially because of all this keyboard shit. Verify that the product that you're looking at supports the platforms that you want to use. Don't just assume that's because it's browser-based, it just works everywhere. You need to check. Audio. You can't, you know, you would have thought, well, browsers support streaming audio. Why don't I just put in an audio tag or something, and I can stream the audio from the remote desktop to the client? Well, that doesn't really work because audio streaming is not really meant for interactive type audio. You get the whole buffering thing, and until it starts, until it stops. It's not really appropriate for how audio works in an interactive environment, like a game or Windows desktop. The way that RDP, for example, works is RDP downloads audio snippets, like short bursts, 360 something milliseconds, 367, am I correct? Something like that. Milliseconds of audio, and then just strings them, one piece after the other. And in order to be able to effectively do something like that in the browser, you need to be able to very accurately schedule when each one of these snippets will play. And the only way to really do that effectively is to use something, a new capability in HTML5 called the Web Audio API. Fortunately, all the browsers are getting it. So it's part, for example, of Safari on iOS 6. It's also in Chrome. Firefox is getting it, and I think IE 10 I think is getting it as well. But not all browsers support it yet, and not all browser remote access clients support it yet. So again, you know, you need to verify. Some products support audio on some browsers. File transfer. You can't do drive mapping. Not really a big surprise. A web page can't access the local file system. So what can you do instead? Well, there are really two approaches that you can take. There are two workarounds, as it were. One is you can utilize a file sharing service, really in two ways. One that I would call, let's say, superficial integration, and another one which I would call deep integration. Deep integration is what we saw with install free, when it's running on top of a file sharing service, really integrating with it. And a shallow approach is a simple one. Just install Dropbox on your terminal server, install Dropbox on your client device, and you can sync files between the two. Not necessarily very secure, but it will work. File upload and download. Well, you know, if there's one thing that browsers have been able to do forever, is upload and download files. So why not utilize that capability? And basically, that's what a lot of clients do. You basically can, let's say, drag a local file onto the browser window, and the browser will initiate a browser upload into that into that host. And I have to tell you that from my experience, in many ways, in my opinion, file transfer for remote access is a much better way to work than drive mapping. Whenever I use drive mapping and I need to get to a subfolder on the local drive, it's just so slow. And with file transfer, it just, you know, you drag it in, you drag it out, it just works. But it is different. So if your users are used to drive mapping, it's a different paradigm. Printing. HTML5 clients also, again, can't access local printers directly. You know, think about it this way. You get to some malicious page and it starts printing porn pictures or what. You know, it's not something you want the browser to be able to do without any type of authorization from the user. So the result, no printer mapping. So what can you do? What some solutions do is they utilize printing to PDF. Basically, you get sort of like universal printing solutions. You get another item in your printer tab, in your printer list. You print to it. It actually generates a PDF file, and then it downloads a PDF file to the browser in the same way that file transfer works. And then you get, let's say, the PDF in a new tab, and you can save it or email it or print it to a local printer. But obviously, if you have like special printers, like label printers or stuff like that, that may require additional configuration or you know, special work in order to get it to work, because otherwise you'll just get, you know, an A4 or a letter size page, and that won't be appropriate. You can also integrate with cloud printing services, something like Google Cloud Print, and then maybe the host would send the print output directly to that cloud printing service, and that would print anywhere. So far, I'm not familiar with any solution that's actually doing that, but I assume that somebody will. Another demo, but I don't have enough time, and so I'll skip that. Future. Performance boosts. You know, a lot of these clients, as I said, these clients are new. They've been around for a year or two. So from my perspective, we're kind of hitting the third stage. The first stage was like the stake in the ground. I have a working browser-based client. Yay! Couldn't believe it would work, but it's working. I can actually use it. Second stage is actually making it into an enterprise product, adding functionality like printing, file transfer, stuff like that, that people need to actually be able to use this in a corporate environment as a useful tool. The third step is going back and actually trying to get everything to work better, to work faster. And I can definitely tell you that the browser-based client will get substantially faster in the upcoming months. And I'm talking about, I don't know, twice as fast or 3 times as fast as they currently are. And also, the browsers are getting faster. All the time, the browsers are getting faster and better, faster and better. So that you're also getting benefits from that. You know, stuff like multimedia redirection. Some products already implement URL redirection. So you can click, you know, think about it. You're running inside the browser. So if a user clicks on a URL, let's say in an email, in the remote session, why not open that as a new browser tab? Well, some of the products already do that. WebRTC. I won't go into details here, just don't have the time. Basically, enhances the browser with capabilities to access audio and video. The camera, the microphone on the local device will enable upstream audio, upstream video for browser-based sessions. So it's not just audio download, it's not just download audio playback, it's also audio recording. You will get that in the near term, I think. Better browsers, better remote access client, especially for mobile. The mobile browsers were shit a year ago. They're still kind of shitty, but they're getting better, much better. We now have Chrome, Safari on iOS 6 is a good browser. The browsers are really improving, especially on the mobile devices. Longer term, video codecs. We were talking about that before. Think about it. Browsers support video. A lot of the newer remoting protocols utilize video or video-like codecs for remoting. So potentially in the future, we could have RFX performance perhaps in a browser-based client utilizing video codecs. WebRTC not only introduces the ability to intercept audio and video, it also will introduce UDP-based communication protocols. So if you think about protocols like PCOIP or the new RFX, may be able to use that. And you can even specify for a UDP communication if it uses reliable or unreliable communication, which could be very beneficial for some of the information you want to remote. I'm done in a minute. And browser programming and native speed. This is a graph that shows how JavaScript performance has improved in Chrome from Chrome 2, which was approximately 3 years ago, till today. It's approximately 5 times, JavaScript is 5 times faster in the latest versions of Chrome than it was when Chrome was released. And when it was released, it was already one of the fastest browsers. We are approaching native speeds in JavaScript, which is amazing from my perspective. As a developer, what they're able to achieve is truly amazing. To summarize, browser-based remote access is happening now. It's not something that you have to say, oh, this will happen in 3 years. No. In my opinion, there are clients out there which you can use today. Not in all scenarios, not for all types of applications, but for a lot of scenarios and a lot of applications. It's definitely a useful arrow to have in your remote access quiver and to be able to use. It's a BYOD enabler for obvious reasons. It addresses a lot of scenarios that are not adequately addressed by native clients, as we saw from that list before. And there are definitely several products and several flavors to choose from. But remember, these clients were not created equal. They do not have the same set of features. They were not even intended for the same purpose. Bottom line, evaluate and choose the product that best suits your needs. That's it. That's my session. Thank you very much. Any questions in the 30 seconds that we have? Yes.
What do you guys do on that improves upon what you get just already?
So first of all, we use in our product we use both client side and server. We use client side. We do support client side rendering. So a lot of the primitives in RDP like draw line, draw circle, draw rect, we actually execute them on the client side, which reduces bandwidth versus other solutions that just download them as images. We also do image compression, so and you can actually specify the degree of compression that you're willing to accept. So if you compress a bitmap down to a JPEG, you can get like a 98% compression. So that can dramatically reduce the bandwidth. And that's important both for speed and also if you're working over a cellular connection, it can be very important, especially if you're paying per megabyte. Really working hard to optimize how we best use built-in browser capabilities and stuff like that. There's a lot of work going on there. As I said, it's a new field, as it were. You know, a lot of the stuff that we were doing in optimizing native clients, we can apply there, but there are also a lot of things that are completely different and new.
You'd also made a comment at the end there that you expect things, performance to improve dramatically.
Yes. Yes, for sure.
Give me a little insight into what's behind that.
Let me gather my thoughts. So it's better utilizing the protocols, especially advances in the protocols that have happened during the recent months. It's stuff like doing merging images. One thing about RDP, for example, the base RDP, I'm not talking about RFX, RDP tends to send all these images as 64 by 64 type images. It turns out that drawing a lot of small images is significantly less efficient in most browsers than drawing fewer large images. So looking at ways of merging multiple images together into larger images that you can draw using a single instruction. You know, doing even more stuff client-side, like with glyphs and stuff like that. We're really working on a lot of tracks at the same time, really there. Any additional questions? Okay, thank you.